What if one decision could launch a nation into the future? No small tweaks, no policy fluff, just bold, unapologetic investment in the foundations of tomorrow. That's exactly what just happened. The United Kingdom has officially committed to investing £86 billion, yes, billion with a B, into research and development over just 4 years. That's over £22.5 billion every single year to build an economy not just of growth, but of transformation. This is the kind of move that doesn't just support science, it stakes the nation's future on it. The UK is pouring massive funding into artificial intelligence, new drug development, long-life battery tech, advanced semiconductor manufacturing, green energy, and regional innovation hubs that will lift entire cities into the modern research age. It's not a side project. It's not a pilot program. It's a full-blown scientific acceleration. Think of it this way. When the world transitioned from steam to electricity, from horse-drawn carts to internal combustion engines, it didn't happen gradually, it happened with massive industrial leaps. This is Britain's leap, and it's arriving at a moment when falling behind is no longer an option. Why now? Because for too long, the UK has been slipping in the global technology race. Let's talk about chip semiconductors. Britain currently controls less than 0.5% of global semiconductor manufacturing. In a world where chips run everything from smartphones to national defense systems, that's an existential vulnerability. Meanwhile, the United States is pumping billions into CHIPS Acts. China is rolling out subsidies like it's a new currency. The UK has realized it needs to get serious or get sidelined. Artificial intelligence? Same story. Yes, London has vibrant startups, world-class research from places like DeepMind and University College London. But the scale, the resources, the compute power, the gap is widening. And if the UK wants to lead an ethical eye, it can't just write white papers. It has to fund the research, build the infrastructure, and train the talent. And that's exactly what this £86 billion aims to do. It's a full-spectrum initiative. £3.5 billion is going into developing and regulating trustworthy AI. Not just building models, but making sure those models align with human goals. £2.2 billion is being pushed into drug discovery through biotech innovation hubs and NHS-backed trial pipelines. That could revolutionize how quickly new vaccines, treatments, and cures hit the public. We're talking months instead of years. Lives saved, entire industries reborn. Then there's the push for batteries clean, long life, recyclable batteries that will power not just the cars on British roads, but the homes, the businesses, the entire grid. And don't forget green hydrogen, offshore wind, carbon capture labs. These are not side investments, they're national infrastructure for the energy systems of the future. But one of the most revolutionary parts of this plan, the regional innovation hubs. For decades, the Golden Triangle, Oxford, Cambridge, and London has dominated UK science. But now, places like Manchester, Newcastle, Glasgow, and Cardiff are being transformed into full-scale innovation ecosystems. Labs, startups, research universities, and industrial applications, all supported by government funding and private partnerships. This isn't just about building tech. It's about building places, a new kind of economic geography, a UK where science doesn't just live in ivory towers but flows through every city, every region. Of course, this won't be easy. Critics are already raising the alarm. They point to previous under-delivered science budgets, promising figures on paper that never translated to real-world outcomes. They ask, will this money be spent effectively or get tangled in bureaucracy and red tape? Will universities finally get the autonomy and funding they need to attract global talent, or will visa policies keep world-class scientists stuck behind borders? And there's the workforce question. It's one thing to build labs and battery factories, but who's going to work in them? The UK needs engineers, researchers, data scientists, lab technicians. This strategy will only work if education and training keep pace. If not, the country risks building cathedrals in the desert. But make no mistake, if this plan is executed even halfway well, Britain could leap into the top tier of global science leaders. Picture this: world-changing cancer treatments being discovered in Birmingham, quantum computing breakthroughs emerging from Cardiff, the world's cleanest energy storage developed in Newcastle. The UK, not as a follower of tech trends, but a leader of revolutions. And this move won't go unnoticed. Already, major science economies Germany, Japan, the United States are watching. Partnerships are forming. Deals are being discussed. The UK's science diplomacy could become as valuable as its scientific output. A new soft power built not on empire, but on data, algorithms, and clean energy solutions. This isn't just about Britain. If done right, this investment could benefit the entire world. New treatments for disease. Smarter, safer, more resilient supply chains. Greener energy for everyone. The impact won't stop at Druva. But £86 billion is more than money. It's a declaration, a message to the world that Britain refuses to fade into scientific irrelevance, that it's ready to build again, innovate again, lead again. So, what happens now? Will the UK become the science superpower it wants to be, or will this funding vanish into policy black holes and institutional inertia? Will this historic investment pay off or become one of the costliest missed opportunities of the 21st century? That's where you come in. What do you think? Will this change the future or just headline the present?